Okay, so this is the final topic of the Unit 12 series, Sum to Infinity and Convergence. Okay, so let's get started. So what is summation? So this is just kind of concluding what we did on the last PowerPoint about talking about a little bit of the summation equations or formulas for geometric and arithmetic series. And now we're just going to be talking a little bit about a couple of other summation tactics like sigma notation, which is a summation of the values of a sequence equaling to a series. So a summation, the sigma or summation looks like this. It's the sigma sign right here. And it will have a value on the top and a value on the bottom and a value on its right side. So the 4 or the in value means the sum, or the total means the sum of the first in terms of a sequence. So you read this if it had an in at the top, but even still. So just read, if you were to read this, it would be the sum of all terms I from I equals 1 to I equals n. Now, I'm going off of the standard form, which has, instead of a 4 right here, it has an n. Instead of an f of n, it has a u with a subscript of I. And then at the bottom, it has I equals 1. And this is just different variables being used. But basically, if you had what I just said, it would make sense because the sum of all terms, u of I, u subscript I from I equals 1 to I equals n. And it tells you how sigma categorizes values that way. So when you represent a sum of values in this form, you are using sigma notation. And this is just one of the things that you need to know. This is also GDC operable, and it can show an infinite summation. Okay, so what is sum to infinity? Let's get on to this. Sum to infinity is the ideal of having an infinite series with an infinite number of terms. Okay, so it's basically talking about how, a geometric series may have, like the dot, 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 or the ellipses at the end of, let's say, 3 terms. And that usually means that there are ongoing terms of which, they can go on forever. Now, if there is an in number, and you have the ellipses in the middle of 3 and one last number, then it means that that last number is the end of the series, or the end of the sequence. And from that, we know that it can't be, sum to infinity. But if it has the ellipses, which are the dot, dot, dot at the end, and that's how it ends the series, or then it usually means you can use sum to infinity. But then again, you'll be learning more about sum to infinity as you go through your book, and you can see certain trends in which that rule may differ. But anyhow, so getting on to the equation, as you can see, you have s, and in place of the in value, you would put the infinity sign, equaling to a, which can be u, it's basically meaning the first term, over 1 minus r. And remember that r, the absolute value of r must be less than positive 1 to fit into a geometric series sum to infinity. So here we go with what is a convergent series. How do you know if a series is convergent? This is the main thing that I guess a lot of people get tied over. And if the sequence of its partial sums tends to a limit, that is when a series is convergent. And basically that's meaning that partial sums are the, the values. And as the values and their terms, so like, as the ratio, or the differences and their terms, their values, become closer to a certain value, and their terms increase, then it's converging to a certain point or a certain end point. And what is convergence? It is the action of items or ideals coming closer and closer together. As you can see on this little graph, see this, both of these equations you have for the blue line, it's getting closer and closer to a point. It's converging. Okay, so a geometric convergence series recap, we need to know, again, the sum of the terms of a geometric series. Again, it's Sn equals U1, open parentheses, 1 minus r to the n over 1 minus r. And remember, that can be changed with the r positioning and the 1 positioning. So again, as n becomes larger, then then you can say that n approaches infinity. So this is a main rule that you really need to know, that as n becomes larger, the n terms become larger. You can say that n approaches infinity. So furthermore, if the absolute value of r is less than 1, then as n gets closer to infinity, as you see right here, that's what it means, r to the n will go to 0, or equal 0. So when going back to your geometric sum of series formula, you can input 0 for r. So if you go back right here, you would put 0 right here in the r position. So this is only in geometric series, only when the absolute value of r is less than 1. Okay, so here's a practice, and it says for this series 18 plus 6 plus 2 plus so on and so forth, find S10, S15, and S infinity, and these are all subscripts if you did not know. So start with formula. This is the geometric series formula once again. It is right here in the blue highlighted, and remember that we're going to try to find our first term and our ratio. So our first term, if we look right here, is 18. We can put that right here. This is our first term. I'll highlight it in blue. And our ratio, very simple. You just have to see the approximate value between 18 and 6 and 6 and 2. And because it's decreasing, it can be a fraction, and it would be 1/3. Okay, so here is a 3-step problem because they're asking you to find S10, S15, and S infinity. And remember, just to recap, instead of infinity written, you'll see the infinity sign, which is a kind of a sideways 8. But my computer wouldn't let me put that in, so I have to just do it like this. Yeah, so like I was saying, this is a 3-step problem because you have S10, S15, and S to infinity. So again, for the first two, because it is basically a geometric series formula, we're going to be using this formula right here because we're just using the basic geometric series formula because we're not summing to infinity, we're just actually trying to find the sum of a geometric series. So basically that's what I did. I input the values. I input U1, which is 18. I left the 1. I put the ratio value, which is 1/3 to the 10th power because of the fact that we have S to the 10. And I divided that by 1 minus 1/3, and I got 26.9995. And just to highlight this for you, 10, this value will always, which is the n power of the r, will always be whatever's given with your sum. So whatever n is connected with your sum. So if we're trying to find s to the 10, this would be 10. So I'll highlight that right there. Okay, so the second one, we're trying to find s to the 15. So I do the exact same thing. I put in 18 because it's still my first term. I leave the ratio, still the same ratio, but what I do differently is that I put to the exponential value of 15. And finally, I will get kind of a semi-different, value, but relatively similar, 26.999999812. Okay, so 3 is a little bit different because of the fact that you are summing to infinity in this case. So you'll have to use a new formula, and this is the formula that you'll use. It is S infinity equals U1 over 1 minus R, and you can see this whenever we go back to right here. This is the exact same formula, it's just that they're using a different variable. You can use any kind of variable you want. You could use X, you could use A, You could use U, but the most common ones are usually A or U. But anyhow, what I'm doing is instead, it's kind of actually a shorter version. I'm still using my 18, but what's happening is this, is that there is no in. Because of the fact that infinity, you're not using infinity as an exponential value. What you're doing is you're taking 18 and you're dividing it by 1 minus your ratio. So you're taking your first term and all you're doing is just dividing it by 1 minus your ratio, which is 1 over 3. And then you'll finally get 27. So it's actually pretty simple. But as time kind of goes on, you'll see how sum to infinity can get a little bit more complex. But not too complex where you can't understand it. So now we're going to do one final problem. It's kind of like an inverted problem where it gives you a couple of things that you have already solved for in the last problem that we did, but it's just a little bit tricky in the way that it's worded. It's also kind of where you'll have to use two separate equations and combine them together. Okay, so this is what it says. It says the sum of the first three terms of a geometric series is 148. Okay, so we know, let's analyze this. Okay, it says the first three terms. So we know that there are going to be three terms that equal out to be 148. And it says, and the sum to infinity is 256. So this is a big thing. I'm going to highlight this. Sum to infinity equals 256. So we don't know the numbers that made up the sum to infinity. We don't know the first term. We don't know the ratio yet. And that's major things that we need to know. However, we do know the sum to infinity, and we do know that the first three terms equal 148. Okay, so I'm going to highlight this. And now what we do know is that due to the fact that this is going to be, a sum to infinity problem, and it's also going to be a geometric series problem, we can start off by using our geometric series equation. So let's just start off by using Sn equals U1 open parentheses, 1 minus r to the n divided by 1 minus r. Okay, so the first equation that we'll have, very simple. We know that there are first three terms. The 3 is going to be our n, because we know that there are terms, and n stands for terms, the nth term. So we're going to put 3 in the n position, and we're going to equal it to 1 minus r to the 3, because we do not know our ratio yet, and divided by 1 minus r. Now, here's the second equation. We want to have sum to infinity equation because of the fact that we have the value of sum to infinity. So we'll put in u1 minus 1 over r equals 256. So here is where we're going to start combining these two functions. So combine equations, sorry. So let's combine these equations. We have u1, open parentheses, 1 minus r to the 3 over 1 minus r equals 256. What we're going to do now is we're going to put them together. And what's going to happen, so we put them together right here. We put the 256 equaling out for the geometric series equation. So we kind of dropped the sum to infinity equation, but not in that way. What we did is that we had more use in this case because we have the nth term, but we equaled this out to be 256, which is the sum to infinity. So this is what we'll do now. We take 256, open parentheses, 1 minus r to the third equals 148. This is just a simplified version of this. And now what we'll do is to kind of simplify this even further, because we already simplified, we got this from simplifying this. Just simple mathematics right there. So now what we do is we divide 148 by 256. And so we'll put 256 under 148, and we'll add 1, this 1 right here, to both sides. So it's going to be, we're actually going to move 1, not add, but move 1 to the other side, and what we'll get is then we'll have 1 over here, as you can see in this, and we'll have r to the third left alone. And this is what we want, because we want to get r, we want